In this tutorial, I will show how to download and run the graphical user interface for Proteinarium, our tool for multi-sample protein-to-protein interaction network analysis. To download the Proteinarium graphical user interface, also known as GUI, navigate to the Proteinarium GitHub page by following the link displayed on the screen. Proteinarium depends upon the Java programming language, so users must first install Java versions 1.8, 9, or 10 before downloading and running Proteinarium. Download the Proteinarium GUI zip file by clicking the hyperlink. Unzip the zip file, which is named JavaFX app, and save it in the directory of your choice. Inside the zip file, you will find the JavaFX app jar file along with two PDF manuals, the Proteinarium GUI manual and a separate configuration options manual, which goes into more detail about each configuration option. You will also find two example GeneSet files which you can use to follow along with this tutorial and to help guide you in formatting your own GeneSet files. To run the Proteinarium GUI, launch the JavaFX app jar file by opening it. Bypass the unknown developer warning and the GUI will appear on screen. This is the home screen of the Proteinarium GUI. You can use the File tab to navigate back to this home screen, start a new analysis session, or change the program's configuration settings. Starting a new analysis will rerun Proteinarium with the same GeneSet files that were specified previously, which is useful if you want to change the configuration settings midway through a run while using the same GeneSet files. You can access the two manual files that I described previously using the Help tab. In the center of the GUI window, you can specify two GeneSet files for running your analysis by clicking the Open GeneSet File buttons. You can run Proteinarium with only one GeneSet file as described in the documentation, but naturally it will not show differentially significant proteins within networks between two groups. You must also define a project name which will be used as a prefix for naming the output files. The output directory will be automatically created and saved in the directory containing the GUI jar file upon running Proteinarium. Let's briefly review how to adjust the program settings. You can adjust configuration parameters by clicking the Adjust Settings button. The max path length setting is particularly useful and tells the program how many imputed proteins will be allowed for finding network connectivity between proteins in the dataset. There are a variety of additional settings available, so I recommend reading the documentation for more information. After adjusting the settings, be sure to click the Apply Changes button, which will overwrite the configuration settings to a file for the program to read during analysis. You can access additional settings by clicking the Advanced Settings button. After changing advanced settings, you must click the Set Settings button on the bottom of the Advanced Settings window. Now that we've reviewed the layout of the main screen of the graphical user interface, let's run an example analysis. We'll use the two GeneSet files included in the download zip file for this example run. First, specify the GeneSet file names and define your project name. Then choose your configuration options. We suggest choosing a max path length of 3, which will instruct Proteinarium to use a maximum of 2 imputed genes, linked by 3 vectors, to find the connectivity between proteins in a dataset. Choose your settings, click Apply Changes, and then click Run Proteinarium. The runtime depends upon the size of your dataset and also on your available computing resources. An output folder will be created in the directory which contains the GUI jar file. Several output files will be written, and the dendrogram will save to file and display automatically. Let's review the dendrogram output. Clusters that have a significant differential abundance of samples from either group 1 or group 2 will be identified by cluster number labels in red text. Samples from the group 1 GeneSet file will be visualized by yellow branches, while samples from the group 2 GeneSet file will be visualized by blue branches. Experimentally speaking, these significant clusters may be case-dominated or control-dominated clusters. After viewing the dendrogram, you may want to investigate individual clusters in more detail. Proteinarium will still be running and awaiting user input in the cluster ID text box. A system output text file will also be written. Inside, you can read information about the run which would normally be returned on the command line version of the tool. If you would like to quit, you can select Exit in the File tab. To view the protein interaction network for a specific sample cluster, enter the cluster ID and click the View Cluster button. Now we'll view the layered cluster graph for cluster 56. A multi-sample layered protein-to-protein interaction network for the chosen sample cluster will save to file and automatically display. Proteins that are only associated with samples in group 1 are displayed in yellow, and those which are only associated with samples in group 2 would be displayed in blue. Proteins that are associated with samples in both group 1 and group 2 would be displayed in green, and proteins that are not found in any samples in the cluster of interest but are imputed to interact between proteins that exist in the data set are displayed in red. The number of allowed imputed proteins connecting proteins that exist in the dataset is defined in the configuration file with the option max path length, which we've set to 3. The number of samples that are associated with the protein in the network is visualized by the saturation of color, as indicated in the legend. You can query additional information about specific clusters by entering the cluster's cluster ID and clicking the Get Cluster Information button. This writes a log to the system out text file containing additional information about cluster 56, which includes, but is not limited to, the number of samples that are in group 1 and group 2, the p-value indicating the significance of overabundance of samples in either group 1 or group 2, and the sample IDs in the cluster that fall into either group. Alternatively, you can examine the protein interaction network within a single sample. You can do this by entering the sample ID for your sample of interest into the cluster ID box. Once you click the View Cluster button, the protein interaction graph will save to file and automatically display. Pressing the Get Cluster Information button will print more information about that specific sample and its associated genes which exist in an interacting network to the system out text file. Now we will review the files that are saved to the output directory while running Proteinarium. You will need to rename your output folder after running your analysis, or else it will be overwritten by subsequent analysis runs. Inside the output directory, you will see the main Proteinarium dendrogram and the dendrogram data files. Additionally, if you chose to explore individual clusters or samples, directories labeled with the appropriate cluster or sample names will be saved inside of the output directory. Within the output directory for an individual cluster, in addition to the layered network graph image file, you can also view the edges of the protein interactions in the interaction text file, with associated weights which are drawn from the string protein-to-protein interaction database which powers Proteinarium. You will also find the GeneSet file, which contains lists of proteins in the network and the number of samples associated with each protein. This is the end of our tutorial. We hope that you will find Proteinarium a valuable addition to your protein interaction analysis workflows. You can reach out to us with questions, comments, or suggestions by submitting an issue on our GitHub page. Thanks for watching.